Hello everyone. Let's learn about the basics of vertical curves in this video. For highways and railways, whenever there is a change of grade in the vertical plane, a vertical curve is required to smoothen the change. So it's usually the parabolic, as parabolic curves provide a constant rate of change of grade. The vertical curves are designed in a manner that it gives a smooth riding qualities, which again will occur if there is a constant change of gradient, uniform rate of increase of centrifugal force, and adequate sighting distance is available before the vehicle reaches the summit. Uh, all in all, these curves are essential for ensuring a comfortable and safe travel experiences, preventing the sudden changes in the elevation. There are a few reasons listed why, in most of the cases, the parabolic curves are preferred than the simple circular ones. They're preferred primarily due to their ability to provide a smooth transition, so that ultimately gives kind of a very comfortable and a safe travel experiences. It is due to, just because it allows a kind of a uniform rate of change in the slope, and in most of the cases they're very simple, and just because they pose a very relative simplicity in computation and laying such kind of curves. The very basic equation that we use to design a vertical curve is y equals to ax square plus bx plus c. Before we learn about this equation and some other very important characteristics, let's learn about the types of vertical curves. So the one that you see first is a kind of a curve which is called as a sag curve, and the next one is a crest curve. Now, how do we define a sag curve? In case of a sag curve, a downgrade is followed by an upgrade. So this is downgrade, an example, minus 2 percentage. The upgrade is plus 2.5 percentage, and the rate of change that we see is basically minus 2 minus 2.5, or you can say 2.5 minus of minus 2 percentage. The change is a total of about 4.5 percentage. So when it comes to the crest curve, what you can see is that there is a upgrade first and then the downgrade, and please see the change. The next one is rising curve. In rising curve, both the grades are upgrade and the upgrade gradients. The falling curve will always have the first downgrade, and then the other one is the downgrade too. Here basically you'd be able to see the changes. It could be the sharp, it could be the smooth changes in the gradients. So basically the vertical curves are the curves which are provided between two grades. Now let's talk about the general equation, and let's see how to connect the parabolic curve with that of a vertical curve. Now let's start with this representation. This is that curve parabola. P is any point which is identified in this curve, p x comma y. How do we approach this p? The y, the vertical distance, and the x is this the distance which is described in x-axis. Okay, so let's get into the equation. Y equals to ax square plus bx plus c. Now at x equals to 0, exactly here at x equals to 0, y becomes c. See, if you substitute x equals to 0 here, y becomes 0 plus 0 plus c. So that's how it is when x equals to 0, we are somewhere here. We are talking about this height actually, which is a c, which is kind of an intercept 2. Now if I can differentiate this equation, it is dy by dx equals to 2ax plus b plus 0. Okay, now you also know that dy by dx is the slope, but again at x equals to 0, again I'm talking about this point, dy by dx becomes equals to b. That means it is some sort of a slope of the tangent at the origin. So we have defined this slope at x equals to 0, which is nothing but b. Okay, now let's do the double differentiation, d square y by dx square. So again, if you could differentiate this equation, it becomes just a 2a. So it ultimately takes a constant form. Now this is some kind of a constant rate of change of slope. Now this 2a further is defined as g2 minus g1 divided by L. L is the length of that curve, g2 and g1 are the gradients, or a is equals to, which is a constant rate of change of slope, is g2 minus g1 divided by 2 times L. So this gives us a very basic idea of calculating something called as a, capital A, which is, remember, it's a constant rate of change of slope. Okay, now let's get back to the concept of so-called the vertical curve once again. Let's try to figure out some of the very basic points here. The starting point, end point, and there is an intersection here. The starting point is somewhere, it is somewhere here, a, which is called the beginning of vertical curve. This is the end of vertical curve, bvc, evc, and there is a vertical point of intersection, which is c here. Okay, so there is upgrade g1, there is g2, which is downgrade. And let's talk about the very same equation once again. Now y equals to ax square plus bx plus c. Now let's try to connect the diagram, the plot, with the equation, basic equation of this curve. Ax square plus b is nothing but, this is that b part, b, it is g1x plus c is this height actually, which is y bvc. It is that depth actually, or it is kind of that intercept. Now c, already as I stated, b is g1, c is y bvc, and a is that constant rate of change of slope, which is g2 minus g1 divided by 2 times the L. So y equals to g2 minus g1 divided by 2L, which is nothing but a, x square plus g1x plus y bvc. Okay, so now we make a very simple substitution here for g2 minus g1 divided by L, which is nothing but, r here. And therefore if you can rewrite this basic equation, y is written as r by 2 times x square plus g1x plus y bvc. Thank you.